let's get right into the practical tools, security controls, and management approaches we actually use to protect cloud environments. We'll be breaking down monitoring, automation, penetration testing, encryption, incident response, and continuous assessment. Our focus here is on realistic, highly effective solutions that make sense for small and medium enterprises.
To properly defend a cloud environment, you need core security tools working together across multiple layers. Think of Security Information and Event Management, or SIEM, as the central nervous system. It collects and analyzes logs to spot anomalies. Out at the perimeter, you've got web application firewalls filtering out malicious traffic, while endpoint detection and response keeps a close eye on individual workloads. Inside the network, data loss prevention steps in to stop unauthorized data exfiltration. Then you have cloud access security brokers governing your SaaS applications, and cloud security posture management continuously hunting for risky misconfigurations.
So what does this look like in the real world? Organizations typically rely on industry-standard commercial solutions to fill these roles. For that centralized logging piece, you'll see SIEMs like Microsoft Sentinel or Splunk. Perimeter defense is often handled by AWS WAF or Cloudflare. When it comes to securing the actual data and applications, platforms like Microsoft Purview, Forcepoint, and Netskope are usually deployed. And for endpoint and posture management, teams rely on robust platforms like CrowdStrike, SentinelOne, and Prisma Cloud to keep the environment hardened.
But we can't just rely on traditional tools. Modern cloud environments absolutely require strict foundational controls. We're talking about robust encryption and key management to guarantee data stays unreadable to unauthorized users. You also need network security controls like firewalls, VPNs, and microsegmentation to isolate workloads and stop attacks from spreading laterally. Tying all of this together is security automation and orchestration. This is crucial because it eliminates human error, drastically speeds up incident response, and ensures your policies are enforced consistently across the entire infrastructure.
For small and medium enterprises, building practical security without completely overwhelming limited resources means balancing 4 key domains. First up is identity and access security, which enforces strict authorization through MFA and least privilege principles. Second is network and workload security, which protects the infrastructure through segmentation and vulnerability management. Third, we have application and data protection to secure web assets and encryption keys. And finally, monitoring and automation, which flags suspicious activity and handles repetitive, routine tasks. The goal here isn't to buy and deploy every single tool on the market. It's about establishing effective, manageable controls across these 4 specific pillars.
A strong defense has to be proactive, and that means rigorous penetration testing to expose vulnerabilities long before an attacker can exploit them. If you're looking at AWS-specific environments, frameworks like Paku and CloudFox are great for mapping out potential attack paths, while Scout Suite is excellent for multi-cloud security audits. When you need to assess your overall posture and compliance, tools like Prowler and Cloudsploit are the way to go. And for very specific threat vectors, we use tools like IAM Action Hunter to expose risky privilege escalations, S3 to find exposed storage buckets, and Rustler to automatically hunt down API vulnerabilities. Put them together, and you've got a highly capable offensive testing toolkit.
When it's time to actually deploy these tools, you always have to weigh open source against commercial solutions. Open source tools give you incredible flexibility, practically zero upfront licensing costs, and deep customization for automated workflows. However, they demand a lot of technical expertise to maintain. On the flip side, commercial solutions prioritize ease of use. They give you professional support, centralized dashboards, and built-in compliance features right out of the box. For SMEs, this choice really dictates your operational strategy. Highly technical teams might love the agility of open source, whereas organizations looking for simplified management usually lean toward commercial ecosystems.
All of these tools and controls ultimately feed into an active monitoring and incident response workflow. It all starts with centralized logging, where you aggregate data from every cloud service into one single repository. From there, automated correlation kicks in, analyzing that massive data pool alongside integrated threat intelligence to spot malicious patterns. The moment a legitimate threat is verified, the system sends out immediate alerts. This triggers automated incident response actions, like instantly isolating a compromised system, so you can neutralize the threat before any real damage is done.
Which brings us to a fundamental principle of cybersecurity. Famously summarized by Bruce Schneier, security is a process, not a product. Cloud security is a continuous, ongoing lifecycle of monitoring, testing, and adapting. You can't just install a shiny new firewall and assume you're protected forever. The threat landscape is always shifting, and system configurations are always drifting. To stay ahead, your defenses have to continuously evolve to meet those new challenges head-on.
To successfully execute that continuous process, you need a highly structured operational loop. First, organizations have to select tools specifically tailored to their environment. Then, you configure comprehensive logging and establish your strict access policies. But here is the crucial part. You have to validate those controls through continuous testing. That's exactly how you uncover compliance gaps before they turn into critical risks. By heavily integrating automation throughout this entire cycle, you ensure your responses are rapid and consistent, which permanently strengthens your overall security posture.
Protecting your data throughout this entire life cycle relies heavily on two specific states of encryption. First, you have encryption at rest. This secures data physically stored in databases, disks, and backups. It ensures that even if someone walks out with the physical storage media, the data is completely unreadable without the cryptographic keys. Then you have encryption in transit, which protects your information as it moves across networks, moving between users and cloud services. By using secure protocols like TLS, you guarantee that data can't be intercepted, read, or altered while it's on the move.
To guarantee that your cryptographic foundation is rock solid, you need to enforce a few vital best practices. First, enable encryption by default across all your storage and databases. Mandate modern protocols, meaning TLS 1.2 or higher. Make sure you securely manage and regularly rotate your keys in dedicated management systems, and use customer-managed keys for your highly regulated data so you maintain ultimate control. I'll leave you with this question. If your cloud environment was breached today, are your encryption protocols strong enough to render that stolen data completely useless to an attacker?